Welcome back, everyone. We're going to power through the last couple problems here. Always check your terms carefully. There's no x squared term. We go from cube to x to 6. X squared is missing. So whether this is long division or synthetic division, we do have to represent the missing x squared. All right. So our equation, technically, is x cubed plus 0x squared minus 7x plus 6. All right, so possible solutions. Factors of 6 are 1, 2, 3, 6, and we're dividing it by 1, which means what you get is what you see is what you get. 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6. The dividing by plus or minus 1 isn't going to change those at all. So we've got 8 choices there. And we've got to figure out which ones we want to use. I try to think a little logically who I think it might be. And so, because I'm not going to remember year from year which one I used. By the way, going back to our choices, this is the only one that would have worked. Substitution, although it meets one criteria, there are 3 terms. 3 is not double of 1. Right? So these exponents here aren't doubles of one another, so it fails there. So that one won't work. There is no greatest common factor other than 1 or negative 1, and there's not enough terms for factor by grouping. So the only choice we have is long or synthetic division. All right, who do I think? I don't know. We got that 7, because I want to have negative 6 at the very, very end. Let's try 3. Let's try 3, see what happens. All right, so 3, and if I'm wrong on 3, I'm thinking it's 2. 1, 0, negative 7, 6. Okay? Bring down the 1. 1 times 3 is 3. Add, we get 3. 3 times 3 is 9. Add, we get 2. Oh, so close, but that gives me a positive 6. Oh, so close, so close. Let's keep that and try. So let's cross off the 3, and let's try. I didn't even go anywhere near the little button for keyboard. I don't know, for some reason it felt I was going to need a keyboard. Oh, smartboard, you were wrong. 1, 0, negative 7, 6. Let's just try negative 3. 1 times negative 3 is negative 3. Add, we get negative 3. Negative 3 times negative 3 is 9. Add, we get 2. Now it works out. We just had off by a sign. So my original thought was 2. Let's see if 2 ends up being one of those as well. All right, so negative 3 worked. All right, and so now we can just factor. Nice easy one here. All right, so we have, this of course is the remainder. We're not going to use that because there is no remainder. And if there was a remainder, it wouldn't be a factor, and then we would just start over anyway. Constant x and x squared. All right, so we have x squared minus 3x plus 2. 1 times 2. We need 2 numbers that multiply to give us 2, add to give us negative 3. Well, obviously, if our middle term is negative and our last term is positive, they're going to have to both be negative. Negative 2 and negative 1 will multiply to give us 2. Negative 2 plus negative 1 will add to give us negative 3. So we have x squared minus 2x plus negative x plus 2. First to our group, second to our group. We'll factor out an x. We're left with an x minus 2. Factor out a negative 1 because you got to start with an x, right? Because that's got to match the thing in the parentheses over here. We factor out a negative 1 and divide. Those signs will change and they'll match. We'll factor out the repeating x minus 2. And when we do that, we have our leftovers x minus 1. Let's not forget our x minus 3. So, I usually change colors, and I didn't change colors on the factoring. Oh, that's all right. There you go. There's from one step to the next. If negative 3 is a factor, excuse me, if negative 3 is a solution, x plus 3 is the factor. You're going to get really good at watching me, at figuring out factors after seeing this so many times. So x plus 3, of course, is not a factor of x squared minus 3x plus 2 any more than it was for all the other problems. But it is a factor of our original polynomial, right? And so just want to represent our polynomial as a product of all of its factors, because that could be a question you were asked. So x, we'll set them all equal to 0. Since I have plenty of space here, I won't skip the step. X minus 2 is 0. X equals 2. So my first choice, remember I said if it's not 3, I think it's 2. Should have used 2 because that would have worked on the first try. X minus 1 is 0. X equals 1. And then x plus 3, of course, we know is negative 3. That's the one we got at first. And I already wrote negative 3 up there. But who didn't I write? Oh, I didn't write 1. So those are our 3 solutions. So I would have been right with choosing 1 and 2. I thought 2 or 3. If I went with 2, I would have been right. But negative 3 worked and it only took us 2 tries. All right. So if you have any questions, of course, you can always ask me in class. Just star in your notes if something doesn't make sense to you or I talk too fast. Of course, you know, you can watch me over, and I think you can slow down the speed and listen to me on 75%. But don't listen to me at 50%, make me sound like a chipmunk. All right, so let's look at our choices. Because I don't want to necessarily, I'm going to write down from the rational root test, but just because we're practicing that. If you are choosing, however, pulling out a greatest common factor, factor by grouping or substitution, you don't need to write down your possible solutions, but you do for number 3, because otherwise you're just, you know, dividing willy-nilly with no plan. All right, so our possible factors, possible solutions, I'm sorry. Since we're using synthetic and it will be solutions. Possible solutions here would be plus or minus, so the factors of 2 are 1 and 2. The factors, that's a plus. The factors of 4 are 1, 2, and 4, right? Because, oops, that's plus or minus there. Right, because 4 is 1 times 4, 2 times 2. So our possible solutions would be 1 and negative 1. And then if we divide by 2, 1 and negative, excuse me, 1 half and negative 1 half. And then 1/4 and negative 1/4. And then if we divide 2, we'll have, divide by 1, we'll have 2 and negative 2. If you divide by 2, you just get 1 again, so we don't need that. And if you divide by 4, you'll have a half, so we don't need that again. So the only ones we could use synthetic division with are these ones here and these ones here. All right? You'd have to use long over here. And by the way, those factors, if you were using long, so 1 half would be 2x minus 1. Negative 1 half would be 2x plus 1. 1/4 would be 4x minus 1. And negative 1/4 would be 4x plus 1. Because that's what you would, when you isolated x, you'd get those numbers there. But let's try something different this time. So in every example we had before, there was no real pattern. Look at these numbers here, 4 and 8. 1 is the coefficient, 1 and negative 2. Notice that 8 is twice 4 and 2 is twice 1. Let's try factor by grouping, because if factor by grouping works, this will be faster. There'll be no, will this work? Should I choose that one? None of that. Let's try factor by grouping. All right, so for factor by grouping, we set it equal to 0. And the first two are a group. And the last two are a group. Once in a blue moon, switching will make a difference, but not in problems like this. It would be a whole different kind of problem. We'll plot our greatest common factor, which is a 4x squared. All right, so if I divide, and notice my exponent is as large as the smaller one. So x squared is the smaller one. All right, so if I divide 4x cubed by 4x squared, I'm just going to have an x. 8x squared divided by 4x squared is 2. Factor out a negative 1. We're going to have an x plus 2. Just the signs will change. Look at that, it worked. So we'll factor out that repeating x plus 2, and the leftovers are the other factor. Look at those numbers. 4x squared, perfect square. -1, perfect square. This is a difference of squares. Go ahead and factor it. By the way, don't set a difference of squares. Don't solve using a square root. It's easy enough to factor it, and you're less likely to make an error. Sum of squares, you have to solve using a square root. Difference of squares, you can just factor. So x plus 2, and then square root of 4x squared is 2x. Square root of 1 is 1. And then the same thing, but with a plus. And there we go. We're all factored. Our solutions are x plus 2 equals 0, so -2. 2x minus 1 equals 0, x is 1/2. And 2x plus 1 equals 0, x is -1/2. So our solutions were -2, 1/2, and -1/2. So the only one we could have done using synthetic would have been the -2. And notice, I said right beforehand what the factor would be. Our solution was 1/2. The factor was 2x minus 1. The solution was -1/2. The factor was 2x plus 1. Do you see the relationship there? Right? So that's how I'm able to do it really quickly, is the relationship. So the sign's going to be the opposite because I would have added the opposite to move it to the other side. And notice that the denominator is the coefficient in front of x. So that's how how I can do that so quickly. And the same thing here. This was 4x minus 1, and this one would be 4x plus 1. So if you wondered how I was able to figure out the factor so quickly, that's all I did. All right, and you can see, so this is a nice one to show you, you can see that really 2x minus 1, if 1/2 is the solution, 2x minus 1 really is the factor. If -1/2 is the solution, 2x plus 1 is really the factor. So this was a nice, easy one, and we're done. All right, let's look at this one. So I have nothing written up there. In your head, I want you to pick, oh, I have one more I could write down. Let's write down our missing one. He gets missed off some of the slides. And that is substitution. Because he wasn't in the, it says, does any one of the 4 techniques just kind of stand out? And you want to say, I think that's the one to choose. Hopefully. However, something else stands out for me, and that is, this is a homework problem. So I don't want to give you the answer to a homework problem. So I'm not going to do this one. However, if I could remember, if it factor by grouping would be the choice here, right? But that one is a homework problem. So we could change it, and we'll do a different one. So say goodbye. Pay attention. Make sure I don't use them twice. Well, he doesn't really want to go away, does he? He's really happy here. The heck with it. Do you go down here? It's just a little too slow when I'm recording. All right, so you're just out of the way. Here, you know what? You're out of the way, out of the way. I'll deal with you later. You bad equations. All right, let's do another one. That would be a factor by grouping. And I'll do one like it, all pluses. All right, so x cubed plus, let's do, now news off the top of my head. Actually, I won't make it that big. Yeah, I can make it that big. We'll do that. All right, very, very similar problem. All right, and so, oops, except for one problem. U. All right, now it's good. All right, so now you can kind of see there is a pattern to this. It looks like factor by grouping might be a good choice. All right, so first to our group, second to our group. Greatest common factor, of course, is going to be the x squared. Right? And that would give us x plus 16. Greatest common factor is just the 1, x plus 16. All right? It worked because we have a repeating binomial. Right? Oh, so by the way, if this is is not in your notes, and don't worry about it unless you would like to write this down, because I already told you it's a lot like a homework problem. If this is in your notes, just change the problem so it says this. So 0 equals x plus 16, and then when we have the leftovers, x squared plus 1. All right, so now this is sum of squares, not a difference. It's not factorable. So we'll solve using square roots. That, by the way, the only thing you're ever going to get is it's sum of squares or difference of squares or something that's not quite squares. And if it's not quite squares, even if it's a sum, regardless of whether it's a sum or a difference, you'll solve it with the square roots. So your two choices when you on that binomial there that you have to deal something with and solve, you're either going to be able to factor it as a difference of squares, or if it's not a difference of squares, then you'll just solve using square roots. All right, so we only have we have two factors here. There's no more factoring we can do with x squared plus 1, but let's get our solutions. All right, so we already know one solution, x plus 16, right? And so that would be negative 16. There's one solution. All right, so now x squared plus 1, not factorable. So we're going to solve using the square root. Got to isolate the something squared. So we'll subtract 1 from both sides. X squared equals negative 1. And now you can see why it really wasn't factorable. We'll take a square root of both sides. Actually, I'm going to write that again because I don't know if I have enough room for the plus or minus next to the equal sign. So square root of x squared equals plus or minus. Don't forget, two solutions. All right? So square and square root cancel. Square and square root cancel. Square root of negative 1 is I. So we have three solutions, right? So our solutions are negative 16, I, and negative I. Right? Only one of them ends up being an x-intercept, of course the negative 16, but we do have the three solutions there. Two of them are complex. So here's our real solution, and here's our complex solutions. All right, so there's a big hint on a homework problem, but at least I didn't do the problem for you. Right? So here's this one. And so if you see that you can use factor by grouping, use that one as your as a first choice over long division and synthetic division. And then if you end up with the sum of squares, or you end up with a difference of squares, or excuse me, a difference of terms, but they're not both squares, a number's not a square, like for instance, what if it was x squared minus 3, 3 is not a perfect square, then just solve using square roots. If you've got a sum of squares, you're always going to end up with an I in it. If it's a difference, but the last one's not a square, when you go to take the square root, you're going to end up with a radical. We also could have ended up with a radical with this one, but negative 1 is a perfect square. So equivalent statements about polynomials. Negative 4 is a solution of x squared plus 3x minus 4 equals 0. Negative 4 is an x-intercept on the graph of y equals x squared plus 3x minus 4. Now that will only be true if it's a real number. If you have a complex number, then it won't be an x-intercept. Another word for that is a 0. Negative 4 is a 0 of y equals x squared plus 3x minus 4. So if it asks you to find the solutions, the x-intercepts, the zeros, right, you're going to be setting y equal to 0 and solving, right? So for instance, with this one here, x squared plus 3x minus 4, whether they ask me to find the solution, the x-intercept, or the 0, right? Or the factors, I'm going to factor it. So if they say factors, it's a good chance, matter of fact, there's a very good chance it's factorable. Right? So 1 times negative 4 is negative 4. Two numbers that multiply to give us negative 4. Add to give us 3. It's got to be 4 and negative 1. So we would have x squared. I'm going to put the negative x first, so I don't have to factor out the negative once more. X squared minus x plus, look how nice the 4x minus 4 look together. Just looks so nice together. And then we'd factor out the x, we have an x minus 1. We'd factor out the 4, we have an x minus 1. And so we would factor out that repeating x minus 1, and then the leftovers are the other factor. All right, so x plus 4 is a factor. When we set it equal to 0, that's why it's called a 0. Negative 4 is a 0. It's a solution. And if that's a real number, whether it's rational or irrational, it's also then going to be an x-intercept. All right? So just some vocabulary, and I'm almost 100% certain, I've given away all my notes, that that is in your notes. The bottom part here is optional for putting in your notes. Just try and make sure I tie the solving, the whole idea of solving, to when you see the words 0 or solution or factor. And that's the end of my podcast. So this one is the shortest of them all. All right, and in the next podcast, we're going to be looking at a review. All right, and so, and it's already done. So you can do it as soon as I post it. All right, so if you have questions, let me know, and bye for now.